Welcome to the second video on grade 9 geometry, and I'm going to concentrate on the parallelogram, rhombus, square, rectangle, kite and trapezium. Before we start with some examples, it is very important for you to know the properties of a parallelogram. So here's the picture. The opposite sides of a parallelogram are parallel and equal. The opposite angles of a parallelogram are equal. The interior angles add up to 360 degrees. And the diagonals of a parallelogram bisect each other. So in order to prove that a quadrilateral is a parallelogram, you will need to prove at least one of the following. A. Opposite sides are parallel. B. Opposite sides are equal. C. Opposite angles are equal. D. Diagonals bisect. Let's take a look at a rhombus. This is a picture of a rhombus. The opposite sides of a rhombus are parallel and all sides are equal. The opposite angles of a rhombus are equal. The interior angles add up to 360 degrees. The diagonals of a rhombus bisect each other at right angles. So important. The diagonals bisect the vertex angles. In order to prove that a quadrilateral is a rhombus, you will need to prove one of the following. A. The quadrilateral is a parallelogram with a pair of adjacent sides equal. Remember, adjacent, I just want to indicate it on the diagram for you. For example, those two sides, or those two sides, or those two sides, or those two sides. And then B, the quadrilateral is a parallelogram in which the diagonals bisect at right angles. And then we're all familiar with the square. The opposite sides of a square are parallel and all sides are equal. The interior angles of a square are equal to 90 degrees. The interior angles add up to 360 degrees. The diagonals of a square bisect each other at right angles and are all equal in length. The diagonals bisect the vertex angles. So in order to prove that a quadrilateral is a square, you will need to prove one of the following. A. The quadrilateral is a parallelogram with an interior right angle and a pair of adjacent sides equal. B. The quadrilateral is a rhombus with an interior right angle. C. The quadrilateral is a rhombus with equal diagonals. Then a trapezium. One pair of opposite sides are parallel. The interior angles add up to 360 degrees. The diagonals of a trapezium intersect but don't bisect each other. They lie between parallel lines and therefore the alternate angles are equal. So as you can see in the diagram, we've indicated it. So in order to prove that a quadrilateral is a trapezium, you will need to prove that one pair of opposite sides are parallel. And then the kite. Two pairs of adjacent sides are equal. One pair of opposite angles are equal. The interior angles add up to 360 degrees. And then the diagonals are perpendicular and one diagonal bisect the other. One of the diagonals bisect the vertex angles, and we've indicated it on the diagram. So in order to prove that a quadrilateral is a kite, you will need to prove that the pairs of adjacent sides are equal in length, or that one diagonal is perpendicular bisector of the other diagonal. So here's example number 1. We tell you that ABCD is a parallelogram and AECF is a rectangle. So now please remember, you need to know all the properties. Then ABCG is an isosceles trapezium. So it means that your two opposite sides are equal in length. So AB equals GC. Question A, calculate the value of X. So we're going to start with E2 being 90 degrees. Now remember, we told you that AECF is a rectangle. So E2 is 90 degrees, interior angle of a rectangle. Therefore, E1 will also be 90 degrees, adjacent angles on a straight line. And now we can work with interior angles of a triangle. So X plus 60 degrees plus E1 must be 180 degrees, and therefore we can get x is 30 interior angles of a triangle. Question B, calculate the value of y. So now we're going to start with angle D is 60 degrees. Why? Because we told you that ADCB is a parallelogram. So we know that our opposite angles are equal. So this must also be 60 degrees. Then you know that DC is equal to AB. Now opposite sides of a parallelogram are equal. But we already know that AB is equal to GC, and that was given to us. So therefore, DC equals GC, which makes y equal to 60 degrees. Angles opposite equal sides in our isosceles triangle. Alternatively, we could also say that C1 is equal to 60 degrees because it's our base angles of an isosceles trapezium. So therefore, y is 60 degrees, alternate angles AD parallel to BC. So ABCD is a rectangle, so remember all the properties of the rectangle, and DECG is a rhombus. DG is 10, FG is 8, so just make sure all your given information is indicated on the diagram. Question number 1 says the length of AB. Now I know that F1 is 90 degrees. And the reason I know that is because of the diagonals of a rhombus are perpendicular. So I can say df squared equals 10 squared minus 8 squared. I work inside this little triangle over here, and that will be Pythagoras. So 10 squared minus 8 squared is 36. And remember, to get rid of the square, you take the square root, and the square root of 36 is 6. However, df is equal to fc, so have a look over here. df equals fc, diagonals of a rhombus bisect. Therefore, my dc is 12. And therefore, my AB will also be 12 because the opposite sides of a rectangle are equal. Right, question B says, determine the length of AD. So now, if I have to determine this length over here, I say DE is equal to 10, adjacent sides of a rhombus. So I already know that that is also 10. Now BE will also be 10 because the diagonals of a rectangle bisect. So that tells me that BD is therefore 20. So if that's 10 and that's 10, it gives me 20. So therefore, I can also say that AB is 12. We've already proved that. And then I can say, therefore, angle A1 plus angle A2 is 90 degrees, interior angle of a rectangle. And then I can use Pythagoras. So AD squared equals 20 squared minus 12 squared, Pythag. So that gives me 256. I need to get rid of the square, so I take the square root. Square root of 256 is 16. So therefore AD is 16, and you can also write there 16 units. Right, then it says determine the size of G1 if A1 is 65. So I can say C2 is 65 degrees, and that will be alternate angles. AB is parallel to DC. Then D3 is 65 degrees, alternate angles. EC is parallel to DC. DG. And then F1 is 90 degrees. My diagonals of a rhombus are perpendicular. So therefore, G1 is 25 degrees, interior angles of a triangle. Then for the last one, it says the size of angle D2. So I know that D2 is equal to D3, and that will be diagonals of a rhombus bisect the vertex angles. But I already know that D3 is 65 degrees. I've proved it already. So therefore, D2 must also be 65 degrees. Example number 3. ABCD is a rhombus and ECFD is a quadrilateral. Now, please note they don't tell you what type of quadrilateral. Then it says over here that BE So let's just put it in, is equal to CF. And then they tell me that AE, so we're going to just put it in here, AE is equal to DF, and that will be 3 units, as you can see there. Then the question says, prove that ECFD is a parallelogram. Right, so we have a list of things that we can prove. So we're going to try to prove that the opposite sides of the quadrilateral are equal. So I'm going to start here by saying that BE equals CF, and they're 4 units each, and that is given. So it's this piece over here. But I also know that BE is equal to ED, diagonals of a rhombus bisect, because we told you that ABCD is a rhombus. So therefore, ED is also 4 units. Therefore, ED is equal to CF. So this side is equal to this side over here. Then we can say that AE is equal to DF, which is 3 units. That's given. But we know that AE is also equal to EC. And that is the diagonals of a rhombus bisect. So therefore, ED is also 3 units. That means that EC is also equal to DF. That makes this new shape a parallelogram because the opposite sides of the quadrilateral are equal. And then it says that we have to prove that ECFD is a rectangle. Now, we already know that E1 is 90 degrees, and we get that from the diagonals of the rhombus are perpendicular because we know the original shape was a rhombus, the ADCB. So therefore, ECFD is a rectangle because the interior angle of the parallelogram will be 90 degrees. That then brings us to the end of this video. Thank you very much for watching. Please remember to like and share this video, and then if you want us to make any other videos on sections that you are battling with, please let us know.